dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Ar-Rahman Rahim, welcome back from Forest. This is our Amano e-learning program. This is video lesson number 4. We came across video lesson number 3. So we were in organic chemistry. We have started alkanes, so we want to continue. These are the properties of alkanes. These are the properties of what? Alkanes. If you consider here, these are the physical properties of alkanes. Okay, alkanes are found in oil and natural gas. What does it mean? We can get alkanes from crude oil. Naturally, we use fractional distillation, then we can get alkanes from the crude oil and natural gases. The longer the chain, the higher the boiling point. What does it mean? Chain, they exist in a form of chain. Carbon do, we already mentioned carbon do what we call catenation. Catenation, so carbon, we can arrange carbon in a form of chain. So the longer the chain, the higher the boiling point. So the boiling point and melting point depends on chain length, that's the point, or the molecular mass. The density depends on molecular mass, same principle, but generally they have densities from 0.6 up to 0.7. If you remember water, the density of water is 1. These two numbers is what? 0.6 and 0.7. So they have a lower dense than water. They have low dense than water. Ferrous 4 alkanes are gases at room temperature, 25 degrees Celsius and 180 and 1 atmospheric pressure. Ferrous 4 alkanes are gases. Methane, propane, butane. These 4 are gases at room temperature. Next 12 start from pentane up to hexadecane. They are what? They are liquids. And the rest are solids. So the rest are solids. Alkanes are nonpolar. They are nonpolar compounds, which makes them insoluble in water. However, they are soluble in nonpolar solvents, which means they are nonpolar solvents. They can't dissolve in water, but they can dissolve with a nonpolar solvents like petrol, cyclohexane, say what we call gasoline. So they can dissolve these nonpolar solvents. Okay, consider this one. Methane is saying up to decane. This is the formula. Physical properties: gases, liquids, and the rest are solids. This is the melting point and boiling point. Say density, number of isomers. We shall see the isomers, but consider density, melting point, and boiling point increase as you go down the group. Increase with molecular mass. It increases with the chain lengths. For example, number 1 contains 1 carbon. 2 contains 3 carbon, 2 contains 2 carbon, 3 contains 3 carbon, 10 contains 10 carbons. So this melting point and boiling point as well as density increases with the chain lengths, Okay, this is the chemical properties. So the chemical properties of alkanes, they undergo 2 main reactions. Combustion and substitution. These are the 2 reactions the alkanes can undergo. So they do what we call combustion, which means they can react with oxygen. Then they produce what? Carbon dioxide and water. Again, they can react with oxygen, they can produce carbon monoxide and water. So combustion, we can say some of the combustion is called complete combustion, others are called incomplete combustion. It depends on what? It depends on the amount of oxygen we have used. So here we have combustion. So complete combustion means burning an organic molecule in air, which means enough oxygen is applied, and producing carbon dioxide and water. So if the combustion produces carbon dioxide and water, it's supposed to be complete combustion. Incomplete combustion is caused by, this is very important, incomplete combustion is caused by not enough oxygen. That's number 1. Unburied hydrocarbons, what we call, we can appreciate UHC, unburied hydrocarbons. So this is the abbreviation. The reaction is rapid. If the reaction is very rapid, sometimes we can say it's incomplete combustion. All hydrogen atoms in an alkene, for example, alkanes are hydrocarbons. They contain only carbon and hydrogen. So all hydrogen atoms in an alkene, when you apply oxygen, are converted into water. Some carbon atoms can form carbon monoxide. carbon monoxide or solid carbon. So this indicates you what? Incomplete combustion. Consider this one. We have a propane, we add oxygen, it produces carbon monoxide, carbon dioxide and water. So if you have a carbon monoxide at the product side, you can identify this kind of reaction as incomplete combustion. Here we have propane, we add oxygen, you have a single carbon, solid carbon. This is again indicates you incomplete combustion. Incomplete combustion. Okay, my friend, I want to remind you, if the combustion produces carbon dioxide and water, this is called complete combustion. Otherwise, it is incomplete combustion. So, what is caused by incomplete combustion? These are the factors that can cause incomplete combustion. Okay, substitution. Substitution, it is a kind of replacement. It is a kind of what? Replacement. For example, alkanes are saturated hydrocarbons. For you to add halogens are much more reactive than hydrogen. So halogens, they can replace one of the hydrogen in an alkane. This kind of reaction is called what we call substitution. Substitution. Okay, consider this kind of reaction. Consider this kind of reaction. Here we have what substitution means: replacing one or more hydrogen atoms in an alkane by other atoms such as halogens. So here we have methane. It contains one carbon and 4 hydrogens. We add chlorine molecule, like chlorine or 2 chlorine atoms. It is a methyl chloride or chloromethane, and this is HCl, hydrogen chloride. So consider this one. Consider this one. So hydrogen, consider this one, hydrogen and chlorine. Hydrogen and chlorine. You see, this chlorine takes the place of hydrogen. It is a substitution. It is a what? Substitution. So 1, 2 or more hydrogen is in an alkane is replaced by another atom is called substitution. This is called what? Substitution. So this kind of reaction is called substitution. This kind of reaction is called what? Substitution. What about cracking? Cracking. Cracking is another reaction. Cracking is another reaction, but we can't use cracking in our laboratories. So cracking is good for industries. That's why we mentioned the 2 main reactions, combustion and substitution. But they also do what we call cracking. They do elimination. They do rearrangement. So what is cracking? So cracking means splitting large organic molecule to smaller ones. Splitting means breaking down large organic molecules to smaller ones for commercial purpose. For commercial purpose. Here you see what we call decaying. It decomposes into octane and ethene. Octane and ethene. So consider here. Consider here. Consider here. This is called decaying. Decaying. It contains 10 carbons, 22 hydrogens. 22 hydrogens. So it can decompose into what? Ethene. It decomposes into what? Ethene. Ethene is C2H4. It also decomposes into C3H6, propene. Again, C5H12. So this contains 10 carbons. So we decompose it into what? 2 carbons, 3 carbons. This will give you 5. And here you have another 5. And here you have another 5. This will give you 10. So we decompose it into what? We decompose it into 2, 3, 5. 2, 3, 5. What about the hydrogens? Here we have 22 hydrogens. Here you have 4, 6. So this will give you 10 plus this 12. So 22. How many? You have here 1 reactant, so it decomposes into 2 or more products. So number 1 is called ethene. This is called ethene. Ethene. This is called propene. This is called propene, and this is called pentene. I say bentane. This is called bentane. So we have three different products. We can use a different. We can use. They have a different uses, different applications. So when you decompose a large molecule into two or more products for commercial purpose, particularly in organic compound, this is called cracking. So this is a cracking. This is a cracking. Okay, some uses of alkanes. Some uses of what? Alkanes. Okay, some uses of alkanes. So uses of alkanes. So we human beings, we use alkane. So an alkanes, they have a lot of what applications in real life. So alkanes, which are gases at room temperature, are widely used as heating fuels. What we call, you know, or you're familiar, some gas. What we call gas cooker. So these gases are always alkanes. So we use what? Heating fuels. Alkanes having 5 to 8 carbon atoms are highly volatile, which makes them useful in fuels. These are called what? Liquefied petroleum. So such as gasoline, petrol. So we use that one as a petrol, gasoline, kerosene. We use that kind of fuels in our cars and machines. Liquid alkanes, 9 to 17 carbon atoms have higher boiling points and are found in kerosene and diesel. You are familiar with these two terms. Kerosene, it can sometimes it can be like a petrol, but diesel, diesel is slightly denser than kerosene. Use it as what? A lubricant. As used what? Lubricant. So they have a lower, higher density than other fuels. What about Vaseline? You are familiar with this kind of what? Vaseline. So we use as a cream, Vaseline. So it is a semi-solid. It is not a solid, but it is a semi-solid, a mixture of hydrocarbon with a more than 25 carbon atoms, and it's used what? Like a cosmetics and lubricants, and also solvent, and also what? Solvent. What about the IUPAC names of alkanes with substituent? So my students, we can't complete this lesson. So I want to stop my lesson here. You see, this IUPAC names or naming nomenclature of alkanes, it requires a lot of time. So because of time, I want to stop my lesson here. So thank you very much.